Good morning, West Platte students. Mrs. P here with 6th grade mathematics at West Platte Elementary, home of the Fighting Blue Jays. Today's lesson is going to be continuation of the discussion we had on Tuesday with our YouTube video, which was the introduction of equations. We are currently in the unit study of algebra, and we have just left expressions, and now we're moving on to equations. On Tuesday, we talked about 8.1 and 8.2, which just was an introduction. How do we solve? How do we write equations? Today, I'm going to continue that with 8.3 and 8.4, again, in your Go Math book that you can look at as you're watching this video, or when we get done, I will post things for you on our Google Classroom. Truly, though, I already discussed this yesterday during our Zoom video, and then I discussed it Tuesday when I made the YouTube video. This is going to work on, or this video and this unit or this lesson is going to work on how do we solve adding and subtracting, or addition and subtraction equations. Two ways that we can do that, and the latter that I'm going to talk about is what I would really love for the students to practice at home. You can model these, and then of course you can use the algebraic mathematical process of inverse operations to solve them, and that's what we would really like the kids to eventually move on to. So I'm going to show you both ways today, and then there are lessons, of course, in the Kids Go Math book if they want to do more practice, and I will send stuff out, as I said, on Google Classroom. But the lessons end up on page 437 and 443, 437 and 443. They know, of course, again, they can look at just the evens and to solve these problems. I will put some up on the Google Classroom, and if they send them to me, then I can give them feedback, which is probably best for them. But I want to show you just what the concept entails for the students. So, lesson 8.3 is about the modeling section, and it just uses addition equations. And then 8.4 goes on to do the addition and subtraction equations. So I'm going to start off with the modeling just to show students how they can visually see this happening. But then I'm going to end up on using our inverse operation process, which is really what we want 6th graders to connect with. We want them to gain that knowledge so that then they can go on to junior high in 7th and 8th grade, and then beyond that in high school when they start doing these things. So I'm going to open up with a simple problem which asks them to model, and this is in their math book for them on page 437. Modeling just gives the students a visualization of how this would take place. I remind students that the problems I give them right now in 6th grade, remember, they're going to be expanded as they make their way through school, and it will get harder for them. And as I'm thinking about this, I'm hoping I'm looking in the right spot for these videos, but it's more about what I say sometimes, as I said the other day, than what they sometimes see me do. It's more about what they hear, and then how they interpret that, and then can go on to evaluate it, and then analyze it and use it. So we're going to start with the modeling of addition and subtraction equations. And I'm going to start with a simple problem as x plus 6 equals 10. Now, you recall the other day I said when your students see this, they're going to have great number sense. Students are already going to be telling you, or telling me right now if I was with them, which I wish I was, that x is equal to 4 because they just have excellent number sense. Well, as I said, this is going to get extended. This is going to expand, and it won't be as easy as what we see now in the 6th grade. The concepts that I'm showing them get expanded, and so they want to know how to do that. For this one in modeling, and they can do this even with ones that are going to get expanded as they go on through junior high and high school. They're going to become larger equations, and they'll be able to do this as well with modeling if that's what they feel they need to do. And even in our lesson next week, where we're going to go to multiplying the equations and using division, they'll be able to see how it's going to be expanded and how they're going to be able to use modeling if they so choose. So for modeling, we know that in an equation it says that my left-hand side is the same as my right-hand side. They are equivalent. That's what that equal sign means. as in the word is. X plus 6 is 10. Now I just need to figure out what x plus 6 is. I know it's 6, but I need to find out what x is. In the modeling sense, I see I have an x. I don't know what x is. But I do also see that I have 6. So I can say there is 1, there is 2, 3, and I think I'll put it down below. 3, 4, oops, I counted off wrong, 5, 3, 4, 5, 6. So x, I don't have a clue what x is at this present moment, but I do know that it's being added to 6, and in this case, we'll just call them number rods. We'll base 10 number rods. So I know that that x plus 6 of these number rods is going to equal 10 number rods. So I will draw out quickly, and remember, not the best. I wish I was Mrs. Minks, our art teacher at West Platte, but I'm not that talented or skilled when it comes to art. So I'll draw out 10 number rods here. And what this is telling me is that this x plus 6 equals this 10 number rods. Well, in modeling, it's fairly simple. I can just look at, well, if I have 6 here, 1, 2, 3, 4, 5, 6, and I see that I have another 1, 2, 3, 4, 5, 6 here, I can then decipher, evaluate, well, I have x left here, and I have these number rods left here. So my x then, of course, must be equivalent or equal to the 4 number rods that are left. Oops, sorry about that. And then I can substitute that x back into my problem to see if I am right. 4 plus 6, does it in fact equal 10? And of course it does. So how does modeling then reflect or add on to us using inverse operations? Well, and I keep taking these tops off and I don't need to leave them on. Well, what did I actually do in the modeling? I took away 6 number rods from here, and that left me with nothing but the x. I came over and I did the same to the other side in the modeling, and I took away 6 of the number rods, and that left me with 4. That's really the inverse operation process, but I'm using it through a modeling system. So my x then equals 4 by me simply taking away whatever is with x so that I can get the variable, the letter, now a variable in algebra, so I can get the variable by itself. And of course I did that. I removed these 6, removed these 6, and my x is whatever's left on this side, which is 4. That's modeling the process of solving algebraic equations. Well, what we really want students to eventually do is to just do this process by using inverse operations. And I did discuss that on Tuesday in the video, and I discussed that on Wednesday when I met with the kids in Zoom. So I'm just going to put the same problem back up for right now. X plus 6 equals 10. So yes, we are concrete learners, meaning visually we like to see something happening. And that's just in anything again in life. And that's why I tell students algebra is so related to your real world. It is the unknown. Well, this is an unknown number. X is unknown. But many things are unknown. How many miles can I go on a gallon of gas? Until you figure that out, you go through the process of driving and seeing how many miles you can go on that gallon of gas. It's unknown. It's algebra. So this x is unknown until I can figure it out. So we're going to use, or what we'd like for the kids to eventually move on using, is what is known as the inverse operations. And it's really what I just did with the modeling. I see I have x here. In the end, I want to solve for x. Well, I have to look, and if I want to solve for x, the best way to do that is to get it by itself. Well, I already see I'm doing something to x here. I am adding 6 to that x. So if I want to get x by itself, I must be able to get rid of anything that's with x. And the only way I can get rid of objects is by doing the opposite things to them. So, or opposite things to numbers, I shouldn't call them objects. So if I am adding 6 here, and I want to get x by itself, and I must get rid of the addition of 6, I simply subtract 6. Again, I'm going to state if I have $6 and I go and spend $6, I now have $0. If again I do that to one side of the equation, I must do it to the other. And if I have 10 and I take away 6 out of that $10, I spend 6, I am left with the $4. So then I see that x is equal to 4. And that's exactly what we stated during the modeling process. In this instance, though, we only use numerical mathematics. We use an algebraic process known as inverse operations. In this case, we're going to call it an algebraic process because we're using it to solve algebraic equations. I use the inverse operation process, and I was able to solve my variable that was placed in my equation. I'm going to do one more here, and then I'm going to let you go, and that way the students can then practice this concept on their own at home. I'm going to go ahead and move to lesson 8.4 and do one of the problems that are there for the students so that they can then see how this is done when they move to that as practice. I'm going to be looking at number 5, which is on page 443. Remember, we are only working with addition and subtraction at this time, so they're using the inverse operations of those two. And number 5 says that W minus 13.7 is equal to 22.8. Now, in this instance, the one thing I want to remind students is that if I have 22.8 over here and I subtracted something, that means that this W variable must be larger than the 22.8 because I had to have something larger over here that I was able to subtract something from to get me 22.8. So in this instance, instead of subtracting 13.7 or 13 and 7/10, so we can keep up to date with our remembering the concepts we've already discussed, I'm going to add 13.7. And this is something we've talked with the students about because they'll look at it and go, I'm going to add 13.7, but I took 13.7 away. If you go, say you borrow $13.70 from mom, and grandma loves you so that she's like, I don't want you to have to owe your mama money. So she gives you the $13.70 back. Well, you still are now at 0, but you don't have it in debt to mom. Now you have it in debt to grandma, but she loves you so that you don't have to pay her back. But you're going to then add 13.7 to get that to balance to 0 and leave you with only the variable. Well, again, one side to the other. I'm going to add 13 and 7/10 to my 22 and 8/10. And of course, we need to remember, how do we add decimals? We line them up. So I get 15. I regroup my 1. That gives me 6. And I have 3. So in this instance, it says that W is equal to 36.5. Again, I always suggest strongly to the students, check your work. 36.5 minus 13.7 is 22.8. 33 and 5/10 minus 13 and 7/10 is 22 and 8/10. I can check myself. Maybe I can move that down just a little bit further. 36 and 5/10 minus 13 and 7/10. Will I get back 22 and 8/10? I cannot take, again, I need to remember to line them up. And I cannot take 7 from 5. So I'm going to regroup with my 6, carry over or regroup my 10 or my whole 1 that I took over there that I broke up into 10 parts. 15 minus 7 is 8/10. 5 minus 3 is 2. And 3 minus 1 is 2. So I do in fact get back 22 and 8/10, which says that I am correct in this solution. So that is what I want the students to work on. There are 2 pieces in their math book for them to practice those skills. I will put it up into their Google Classroom. If they have tons of questions or a few questions, I hope they have questions, they can always contact me through email or Google Classroom. Until I see them tomorrow, we are all going to Zoom together to have a discussion. I hope they're all doing well. I thank you again and take care of each other. Bye-bye for now.